All right, so here we go. So for today, here's the plan. We're going to close them all up all the way. I want your undivided attention here.
Come on, don't be watching that.
So for today, we're gonna just take one more step. This is a pretty easy section. We're gonna take a step where we're going to focus on graphing quadratic functions in the other forms. We already know how to graph quadratic functions in vertex form. That was Unit 3. Right? We spent a lot of time on that. Okay. But now we want to look at the other two forms. How can we quickly and easily graph a quadratic function in general form, standard form, or in factored form, which we could also call intercepts form. That's the other thing some books would call it, is intercepts form. Okay? All right, before we do that though, I want to review a problem that I feel probably needs reviewing, because this is probably the hardest thing we do in Unit 4 algebraically. This would be like, for example, the last problem-ish on the 4.3 practice. Okay, so if you had trouble on that last section, especially like the last problem or two, let's go through one like that. There's a little bit of stuff going on here. So let's think about what are the steps we're going to do. Our goal is to rewrite this function that's in what form right now? Standard form. We want to rewrite it in vertex form, right? So we're trying to go from here to there, right? Notice one thing. Now let's kind of break this down into a strategy. Think about this in big chunks. So one chunk is, notice that when this is in vertex form, we've got a perfect square in it, right? We've got x minus h. H is a number, quantity squared. So there's a perfect square. So what do you think our strategy is going to revolve around? What process are we probably going to have to do? Say it again. Completing the square. Yeah, right. We want to go from f of x. Here's our starting line. F of x equals 3x squared plus 36x plus 211. We want to turn that into vertex form. And the whole strategy is going to revolve around the process of completing the square. So think back to the kind of stuff we did when we completed the square. We always had to start off by setting it up to complete the square, right? We had to we called it our starting line for completing the square. Remember, we had to get it where the part where we were going to complete the square, we wrote it in the form x squared plus bx. Remember that stuff? Okay, so the first big step is we've got to get the right side of our equation must be in the form, oops, not that, x squared plus bx, right? So what are the things we've got to do to get this into the form x squared plus bx? So one of the things we're going to have to do is we're going to have to divide by 3, aren't we? Because we don't have an x squared, we have a 3x squared. What else are we going to have to do? Subtract 211, right? So we got those two things we're going to do. Which order? Well, if we're trying to isolate, right, we want to add or subtract first. We're trying to get rid of stuff. So we're going to add or subtract first, and then we're going to divide, right? So the parts of this process, call this step A. Step A, we're going to subtract 211 from both sides, right? So we end up with, oh, and before we even do that, one thing I should have done at the very beginning, before we do anything, we're going to rewrite this in terms of y's, okay? So we want to rewrite this. Instead of f of x, we're going to write it as y equals 3x squared plus 36x plus 211. And the reason being, as we talked about in class, remember, just the y looks easier. It doesn't look so jumbled up, right? It looks less complicated, and this thing starts to look pretty complicated. So step A was we were just going to subtract 211 from from both sides, right? So that gives us y minus 211 equals 3x squared plus 36x. Then you said divide by 3, right? Yep. So if we divide each side through by, is that what that? This is b. If we divide each side through by 3, what do you get? Well, if I divide a bunch of terms by 3, that's a common denominator, right? So we could separate that into 3x squared over 3 plus 36x over 3. And what's that give us? What do we get on this side? X squared. That's good, right? That's what we wanted. X squared plus 12x. So far, so good, right? We got what we needed. We got it into that form, x squared plus bx. Right, so step 1 was we got the right side ready to complete the square. What do you think big step 2 is going to be? We got it ready to complete the square, so now what are we going to do? Complete the square. Yeah, so step 2. Complete the square. Okay. So we've got y minus 211 over 3 equals x squared plus 12x. So to complete the square, there's just 2 parts of that. We got to add the right number to both sides. What's that number going to be?
36.
How come? You're right. Okay, half of 12 is 6, right? So it's going to be, we're going to add 6 squared to both sides, which is 36. You've got to treat both sides equally, right? Okay, so then what does that all work out to be? On the right side, what perfect square is that going to be? What numbers multiply to 36 and add to 12? 6 and 6, right? 6 and 6. Okay? And on the other side, we just get this big mess. Okay, don't try to be fancy with that big mess and get a common denominator. It's just a waste of time. Because all we're going to do in the last step is isolate y. We're going to reverse all the things that we did to isolate y. Okay? So the last big step, step 3, reverse the steps to isolate y. When we're isolating a variable, that's just we're going bottoms up on PEMDAS, right? Okay. So what are the things we're going to do in order then to get that y by itself? That's our goal. So the first step is add or subtract. What are we going to add or subtract to both sides? Subtract 36. The very last step that we did in step 2 is going to be the first thing that we undo in step 3, isn't it? Right? So we subtract 36. So if we do that, we get y minus 211 divided by 3 equals x plus 6 squared minus 36. Now what? So we did that. Now what?
211.
Say it again.
Add 211.
Not yet. How come? That's too early because we're on the multiply divide step. Well, where is the parentheses step? Now, we didn't write these in here, but technically, if you have a fraction, everything in the top is in parentheses and everything in the bottom is in parentheses, right? Okay, so we can't deal with anything in here until we get up to that last step. Right now, we're just on step 2. What's that mean? Multiply by what? 3. Yeah, I gotta undo the 3 on the bottom. Okay? So I'm running out of space. So I gotta go to another page here. So that's where we left off, right? Pretty tricky, huh? So step 2. Step 2. Three over 1 times y minus 211 over 3 equals 3 times all this stuff, right? But if I'm going to multiply, there's an important point to be made here. If I'm going to multiply both sides of an equation by 3, I got to multiply everything on both sides. So what's our way in math of saying everything? How do I group everything together? What's that the universal sign for? Yeah, I guess. Maybe that wasn't what I thought it was.
Do it again.
I'm good. He's good.
I'll give you a quarter.
So what is it?
Circle.
No, not infinity. No, how do I, if I'm going to multiply, now you guys are making this too complicated. I probably, no. It's parentheses.
I said that earlier.
I'm going to make them brackets. Okay, that's what I was wondering if that was a bracket. That's what I was thinking.
Yeah, brackets.
Right, because we got to do the same thing to both sides. If I'm going to multiply a 3 by this side, I got to multiply a 3 by this side. Well, this side is the whole side, right? So I need the whole thing in brackets or parentheses. So it's a grouping, right? So on the left side, if I multiply, 3 times something divided by, or 3 over 1 times something over 3, don't the 3's just cancel? Okay. On the right side, what do I have to do if I'm multiplying 3 by more than one term? Like, for example, you've done a ton of this stuff in the past. What if you multiplied 3 by 2x plus 4? What would you do? You distribute, wouldn't you? Because you're multiplying by more than one term, and so you've got to multiply both terms by 3, right? Same thing here. Okay, say it again. You're right. You're right. And so don't try to do too much with this. How many terms are there? Well, there's 2. This first term is big. It's a quantity that's being squared, but you're not going to try to do anything inside that. But you've got something minus something, right? So when I distribute the 3, I have to distribute it to both of those terms, right? So we end up with, over here the 3's cancel, so I get y minus 211 equals 3 times the quantity x plus 6 squared minus, what, 108? Okay, now, that's okay though, right? Isn't that what we're supposed to get, is something like that? That's starting to look better, doesn't it? It looks like a number times a quantity squared. Ah, okay, that's good. And then the very last thing is what? Add 211, right? So the 211's cancel, right? And we end up with y equals, I can just combine those like terms. So I get 3 times the quantity x plus 6 squared. What's negative 108 plus 211? Plus 103. And I guess the very last step would just be to turn that into f of x, right? There it is. There it is. Okay, make sense?
Yeah.
All right, give yourself a round of applause.
We just solved that problem. Is that right? Yeah.
That was right.
Yeah.
Oh, okay.
Yeah.
I forgot to figure that.
Let's
Okay.
move on to the next problem.
No, let's move on to the next one. There you go. Okay, so now on to the stuff. That was our review of a hard problem from the last section. Now let's move on to the new section. So we're graphing functions in other forms. How about if we just quickly go back and do a review problem from Unit 3 to remind ourselves how this works. So we can make short work of this. This is easy stuff. So we've got this in vertex form. In vertex form, we want the values of a, h, and k, right? So what are the values in this function? What are the values of a, h, and k? A is -6, good. And h and k are what? -4 and 2, right? And if we're graphing a function in vertex form, it's dead simple. We're just, the vertex goes at hk, right? So the vertex is going to be at -4, +2. -4, +2, right? And the vertical dilation factor, that's just telling us how much we're going to stretch out or compress and maybe even reflect our parent graph, our parent parabola, y equals x squared, right? The easy way to do that is, it's what we multiply all of the parent y values by. When I say parent y values, I mean, like if I were going to, normally, if this is my vertex, I would go 1 to the right and 1 up, right? Normally I would go 2 to the right and 4 up, right? 2 squared up, right? Because it's just y equals x squared, right? So we're just squaring the amount we're going, x is changing by, we're going to square to get how much y is changing by, right? But that's really the only one we need here. Normally we would go up by 1, but our value of a is -6. A is what we multiply by the original y values, right? So -6 times 1 is -6. So instead of going over 1 and up 1, we're going to go over 1 and down 1, 2, 3, 4, 5, 6. Right? So there's going to be, everybody with me? Oh, no, it wasn't you. Tell me to reread his.
Oh my gosh, so I walked into for nothing?
Yeah.
You can really tell she does.
Yeah. Yeah. Can you feel the love?
Oh, yeah.
That's what I feel all the time. No. She's very lovely. So, so there's one point, right? It's from the vertex. Every time I get a point that's not on the vertex, there's another point I want to make. I maybe haven't emphasized this enough. All the points have this reflective symmetry, don't they? We kind of talked about this on a parabola. We've got if I make a folding line, right, a vertical line through the vertex, we can always fold one half of the parabola over to get the other half of the parabola, right? Now let's just talk about maybe the anatomy of a parabola for a second. Let's define some of these terms. So you guys know this is the vertex, right? That's the vertex with coordinates h and k. This line that we fold over, like that, that's what we call the axis of symmetry, right? The vertical line through the vertex is the axis of symmetry because the function has that folding symmetry over it. So what we're able to do then is if this is one point, then I can reflect it over to the other side and get the other reflected point. And I mean, I'm not telling you anything super profound. You guys know all this stuff, right? I mean, we've talked about this before, but I just want to just do a review. So then when I graph, this is so hard to draw this whole.
Star Trek.
Oh, that's
That's
not
pretty good.
So there's my parabola, right? We're good. Okay? We could do that in reverse, and we did. What if I give you one and I want you to write the function in vertex form? All we have to do is inspect the graph and extract from the graph the values of a, h, and k. H and k are free. What are those? Yeah, so what are the coordinates of the vertex? -5, 4, so that's hk. So we got those guys. Now what about a? It's not -1/2. It's close. Not -1/2. So now we got to think about this in terms of what did we do to the parent graph. So we went from our vertex. We went to the right, so x increased by 2, and we went down. Y went down by 1. Normally we'd go over 2 and up 4, right? Well, normally we would do this. We'd go over 2 and oops, that stuff's all kind of getting in the way. Oh my goodness. Oh my goodness. Well, I kind of messed this up. Okay, normally we'd go over 2 and we'd go up.
Choose a different color.
Thought I did that. And we'd go up 4, right? But we didn't. We went over 2 and down 1, right? That make sense? Is that 4? Yeah, it is. Okay. We went over 2 and down 1. Right? And so that must mean that if we multiplied A times the parent y value, that would equal the new y value, the dilated y value, which is -1. So what's A? -1/4, right? If I just divide each side by 4, don't I get the value A equals -1/4? Makes sense, right? Think what that's doing. The negative is flipping it, so the parabola is opening down instead of up, right? And the 1/4 is compressing it, so instead of changing by 4, it's only changing by 1. Agreed? Yeah. And so if we just plug that stuff in, we get -1/4 x minus -5 plus 4, right? Escape. All right, so new stuff. So what about if we're going to do the same stuff, only this time we're going to try to graph a function that's in standard form instead of vertex form? Okay, well, there is no direct way to do that. There's no connection to make between A is the vertical dilation factor, but B and C don't really tell us very much about what the graph looks like. So we're going to kind of use a little trick here. We're going to go about it the same way we did before. We want to find the coordinates of the vertex and then use the dilation factor A, to give us another point that we can get the shape of the parabola, right? But in order to do that, we need a little extra push. We need a little formula. And so there's the one thing you got to remember. H is equal to -b over 2a. So the x coordinate of the vertex, h, we can always get very simply by just plugging in the values of a and b into this formula, okay? And then for any function, if I have an x value and I want to find the y value, what do we always do? For any function, if I know an x value and I want to find a y value, yeah, plug in the x value into the function, and that gives me the y value, right? Just plug it into the function and see what we get. Okay, so then let's try an example. What about one like this? So what are the values of a, b, and c? It's in standard form, right? So what's a? Yeah, I heard it 1/5. What's b? What's c? Okay, so then h equals -b over 2a. So what's that? What's -b? 2. 2 times a. What's 2 times 1/5? 2/5, right? Okay? Right? If I just multiply fractions, I multiply straight across. So 2 over 1 times 1 over 5 is just 2 over 5. Now, what's my rule going back to like pre-algebra? If I divide by a fraction, what do I always do? I multiply by the reciprocal, so I flip and multiply, right? So this is just equal to 2 over 1 times the reciprocal denominator. So what happens to the 2's? Cancel. And I get, okay, so h is 5, right? Now what about k? Well, k is just going to be, that's the y value, so that's just the value of the function when I plug in h, right? So what's that give me? I get 1/5 times 5 squared. What's that? 25. So 1/5 times 25 minus 2 times 5 plus 7. Well, what's 1/5 times 25? 5 minus 10. -5 plus 7. +2. So k is 2, h is 5, a is 1/5. That's all we need, isn't it? Right? So we know that the coordinates of the vertex are going to be at 5, 2, right? HK. And if A is 1/5, now this is the part that's a little tricky. Right, so we want to multiply the original parent y values by 1/5. Let's think about the ones that would make sense. Would I go over 1 and up 1? Multiplying a y value of 1 times 1/5 doesn't help me very much. That's a fraction. If I go over 2 and up 2 squared, 4 times 1/5, that's not good. Over 3 and up 9. So I multiply 9 times 1/5, no good. 4 squared is 16. So if I go over 4 and up 16, still no good. If I go over 5, I go up how far normally? 25. 25 times 1/5 is what? 5. Okay, so we go over 5, and we're going to go up 1/5 times 25 equals 5, right? So I go up by 5. So that's it. So our function just looks like, and then I could reflect that point over the x-axis, or sorry, over the axis of symmetry, over to there. I get, man, those are good parabolas today, aren't they?
That's
So I'm the master of parabolas, I think.
But you have it on film.
I know.
You're gonna get this on film, right?
It's on film, it is on film.
Well, I mean, like, are you gonna get it, like, made in?
Oh, yeah, feature-length movie,
35.
my parabola skills, for sure. Okay, so what about one like this then? The good news here is, the good news or bad news is, there's really nothing we can do. Like if I want to take this function and write it in standard form, there's no way to do it directly. I would do it the same way I did the last example a few minutes ago, where I would put this into vertex form, right? What are the values of A and H and K here? So H and K are what? -4, -3, okay, I'll buy that. And what's the value of A? Instead of going over 1 and up 1, I'm going up 3. So what I multiply my y value by? 1 times what is 3? 3, okay, so A is 3. And so then all I would do is I would write this first of all in vertex form. And then what would I do to put it in standard form? Section 4.3.
Will you use, like, how we find H but manipulation?
No, nothing that hard. This is just regular algebra now, right? There's my answer. That's the function that fits this graph, right? But if I want to put it into standard form, no, I don't
So
do
you
it.
want me to expand it?
Expand it. Just going to multiply it, simplify it, right? Just multiply it all out and collect like terms, and when all the dust settles, it's in standard form, okay? All right, last example. And then I know it's a lot of stuff, so I'll give you a work day tomorrow to get questions answered, okay? So now here's one that's in the other form, which is factored form, right? Let's go back real quick to factored form though. So we know that you told me when this is in vertex form, A is the vertical dilation factor, H and K are important, those are the coordinates of the vertex. Standard form is nothing, B and C don't mean anything, right? But factored form is easy. P and Q do mean something. If you remember what P and Q are. And I'll give you a hint. If I want to know where f of x, which is y, equals 0, that's a pretty good hint. That would give me the equation a times x minus p times x minus q equals 0. What would be the solutions of that equation? What are the values of x I can plug in and get 0 for my answer? If I plug in 0, I would just get a times negative p times negative q, which probably isn't 0. But what if x were p? If x were p, I'd get a times 0 times some number is 0, right? What if x were q? I'd get a times q minus p, which is some number, who knows, times 0 is 0, right? So p and q are literally the zeros of the function. In other words, they're the x-intercepts, right? So when we write this thing in factored form, never forget that p and q are the x-intercepts, right? So this becomes a really simple problem then, doesn't it? If we're trying to do one like, oh, we did a lot of math today, didn't we? Like that, what are the x-intercepts? What are the values of p and q? P is what? Not 11. Negative 11. And Q is negative 7. Those are the values that would make 0, wouldn't they? Right? So if we graph those, negative 11 and negative 7 are the x-intercepts. Now this is a parabola, right? It's got that symmetry. Can somebody tell me here, what's the x-coordinate of the vertex?
9.
By 9, I think you mean
Negative 9.
negative 9. How'd you get that?
You just cut it in half.
You cut it in half. You used symmetry, didn't you? Right? You know that it has to lie on that axis of symmetry, right? Because it's got to have folding symmetry, so it's got to be in the middle of the x-intercepts, doesn't it? Right? So that's easy to see graphically. How could we find that maybe more generally? If I had numbers for P and Q, and maybe they were weird numbers where it's hard to see what the middle value
You
is.
just add them both up, and then you divide by 2.
Yeah, middle is average in math, isn't it? Right? So we could always just add them and divide by 2 to find the x-coordinate of the vertex, which is just age, right? That's what we call age. So we know in this case that if we combine those, we can see that h is their average. Negative 18 over 2 is negative 9. And once again, this should be like a broken record here. If we know an x value and we want to find a y value for a function, what do? Plug it in, right? So k is just going to be the y value is just whatever I get when I plug h into the function, right? So if we go back up here then, if I plug in negative 9 into my function, well, we know that k equals f of negative 9, which is minus 1/4. What's negative 9 plus 11? Negative 9 plus 11. 2, good. What's negative 9 plus 7? Negative 2. What's negative 1/4 times negative 4? Negative 1/4 times negative 4.
Negative 1.
Wow. Positive 1, right? Negative times negative. So k equals 1, h equals negative 9. So negative 9, positive 1, we're done, right? All we got to do now, see if I can keep my parabola straight going here. Right.
Watch out for pasta.
Okay, make sense? Okay, I guess I need this. So there it is, right there's our summary, okay? If we're trying to graph a function that's in factored form, sometimes people call it intercepts form, all we got to do is plot the x-intercepts, find that h is the average of p and q, right? And then plug that into the function to find k, and that's all I need. I already have these 2 points. If I had a vertex, all I got to do is connect into a nice little parabola. You're not going to be as good as I am at that, of course, but you can try your best in making this problem. Okay, right? All right.